All right.
It was.
You know, if something don't go your way, who do you blame?
The Russian.
The Russians. Yes, it's the Russians' fault. All right. So, let's go make fun of people, and let's go to the. If I could get my mouse to show up, can y'all see it? It's not even. There it is. There we go. All right. I want to go to My Labs Plus, and let's look at all the campuses so we can make fun of people who still haven't registered. So let's do that. Oh, I got my grandmother died, and I don't need that. tct.mylabsplus.com. Oh, while I'm at it, is there a David Saliba up there at Pendleton? Saliba? Okay. Because you weren't on the attendance tracker, and I wanted to ask. What the heck is this? See, I've told you, Russians, they get into everything. What an operator error is Russians. Don't blame yourself. Blame the Russians. What the heck?
Have me understand. I'm a kid.
I'm going to start blaming somebody else. There we go.
Do you add the cake? I don't remember. Yeah. Wait. I think so. I think I was. My cake.
You know what's so bad about it is I blame the Russians and people don't have any idea what I'm talking about. That's what's sad. All right. So y'all are Math 109, and there is the first one. That's the Oconee campus. The Oconee campus has 2 or 3 people. I think 2. But let's see how many are registered. Kind of going to be hard not to make fun of some certain people because there's only 2 in the class. So, and there is 3 in the class. So everybody give the Oconee campus a big hand because they're all winners. That's a joke. You're not supposed to clap. All right, let's go to the Easley campus and see who sucks there. Nobody sucks at the Oconee campus. They actually follow directions. Let's see. Oconee campus. Let's go to the campus. You'll see EC on there anywhere. Thought I saw it. There. Let's see how many. We've got 1, 2, 3, 4, 5, 6 people on the roll, and 6 people have the Easley campus. Don't suck. They're winners.
Yeah. That's right.
We're going to find some losers somewhere. I bet it's going to be the Pendleton campus. Let's see. The Pendleton campus has, golly, I can't even tell how many people. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many people are in the classroom? Somebody count right quick.
Come on.
Can y'all count at Pendleton? Y'all can count, can't you? Looks like you got 11. Wow. And that must mean the Anderson campus is going to suck. Let's look. The Anderson campus has 1, 2, 3, 4, 5, 6, 7. So let's look at the Anderson campus. Y'all see? 5. There we go. We got 2 losers. There we go. I knew we'd have some losers somewhere. We got 2 losers at the Anderson y'all want to go ahead and say if your grandmother died 5 times or what? You got 5 flat tires or what? Lightning struck your house, right? Okay, y'all not going to say it? Okay. Well, I'll say it for you. Your dog ate your computer, right? All right. All right. Who's got questions? Any questions on... Everybody looks like they're getting on okay. So since 90% of the class has gotten on to MyLabs Plus, one of 2 things. Both 2 things. One, the directions are working and the access codes are working. So that means that the only reason people hadn't registered is because of maybe they hadn't got to it yet. Okay. 2 means we're going to start today on math. So everybody can get all happy about that, because I know there's one person out there going, oh, I wish you'd start on math. Whatever. Okay, so that means we're going to start on chapter 1 and 2 in your book. So let's see if this thing's going to blow up when I pull up chapter 1. So right now you should be getting out your notebooks and all that good stuff and being studious. You need to do that. Chapter contents, chapter 1. Do I give y'all, I don't give y'all, no I don't. Okay, functions and models. So here we go. 1.1, I'm just going to look at it, see what it looks like, because I usually don't follow the book very well. If you're one of those color in the lines people, I'm not going to really take it. So I'm going to look at it, and then I'm going to take off. So if it ever comes up, we are talking about Tri-County Tech IT department, so it may not come. It may just sit, there we go. Functions and models. How do you go to the next page? This is a new format. Here we go. Okay, it looks like to me we're talking about. Now just give me a second. How far do we go? 1.3? Somebody look on out. I got it right here. 1.4. Okay, I know what we're going to do now. All right. So, get out of this, pull up my handy dandy whiteboard, and we're going to pull up functions. All right. Now, I don't know how many of you have had Math 102 in the last semester or the last couple of semesters, but I'm going to assume that there's one person out there that hadn't had Math 102 in a couple of years. Okay, so we're going to start from that. You can write down what you want to. You can, all I ask is that you keep your mouth shut. If you're bored out of your skull, that's fine. Somebody needs to maximize that. I see, they don't even have that room. They don't even have that room set up right. Okay, first of all, JC, do you see a remote control around there, a white remote control?
No.
Okay, look around. There it is. It's over there under the TV. You didn't even have the dadgum room set up right. Over there under the TV. Isn't that a white remote control right there?
Wait behind you, over there.
Don't y'all see that white remote control? The Anderson campus sees it. It looks like this. Can y'all see that white remote control?
I got it.
All right. Now, point it toward that whiteboard over there. Behind you. Okay, hit the blue button. And it should turn on the projector. My God, I can't believe that. Did your class go through the whole class and it wasn't even on?
She had it on and she couldn't figure it out or something.
Oh my Lord. Okay. Same thing. What about Easley campus? Do y'all have a big whiteboard with a projector?
Yeah.
Turn it on, please.
It's on.
Okay. It should be showing my whiteboard because that is the biggest board. Okay, so you need to move my display over to that big whiteboard so it will be big. Oconee campus, do you have a big whiteboard or is it just TV monitors?
It's just the monitor. It's just TV.
Okay, they're ghetto, so they're in projects, so they don't get a whiteboard. All right, y'all try to move the white screen that says desktop new. The screen that y'all should see right now is my whiteboard. You need to move that over to the whiteboard, and then you need to maximize it. Okay? Now, who's got the mouse at the Pendleton campus? Who's got the mouse? JC, you see the picture of me on the whiteboard down there in the bottom right-hand corner?
Oh, man.
Okay, there's a white arrow over to the right of the picture. I need you to click on that.
Did it turn on?
And when you click on it, you should be able to move my picture over to the monitor, the TV monitor. I can't believe I'm having to tell students how to do this. This is so The same thing with the Easley campus. All right, you see the little white arrow beside my picture? JC.
Yeah, I got it.
Okay, you need to click on it.
Hang on for a second.
When you click on it, it'll make that a box that you can drag over to the other screen. You've got to click on the little white arrow. It should be to the right of the picture of me.
Little arrow.
Move over to the right. I can't see it, just went away. I can't see it now. Pendleton campus camera just turned around, so I can't see it. Easily, how are you coming? Can you move it over to the whiteboard?
Yeah. Yep.
Okay, now the picture of me, there should be a little white arrow beside it. You got to look for it, click on it, and it'll make that big, and then you can drag my picture, or what the feed from Anderson campus, you can drag it over to the TV screen and make it bigger. That's the way it's supposed to be set up, so everybody can see it. You got it?
Yep.
Okay, that's the way it's supposed to be set up. Maximize. Okay, make sure that the presentation screen, make sure it's maximized on everything so you can see it. Okay, I'm sorry. Sorry I had to go through that. Anyway, we're going to talk about functions. Now, a function is pretty much something, let's just talk about an ice machine. Okay, there's an ice machine. Makes ice. You open the door, you scoop ice out of it. All right? In order for an ice machine to work, you got to have something coming into it. And what is that? Water. You got to have water coming into it. And therefore, the output is ice. Now, let's say that, okay, y'all don't know what this is, but a lot of people do. You have a funnel. Y'all wouldn't know what that is. But anyway, let's say you have a funnel. And let's say instead of water, let's say you put 5 gallons of, no Alcoholics Anonymous in here, okay, of cherry Kool-Aid. Okay, instead of water, you put 5 gallons of cherry Kool-Aid in that funnel, and it goes to the ice machine. Then what are you going to get in return? You're going to get 5 gallons worth of what? Cherry ice. If I put 10 gallons of lime Kool-Aid, which is nasty, but if you put 10 gallons of lime Kool-Aid in that funnel that goes through the ice machine, you're going to get 10 gallons of lime ice. Okay? Whatever you put into it, you're going to get what? Out of it. So, we can say that this is the input. I hate this. God bless it. Sorry. You got your input. I've asked for it to be moved several times and they won't move it, so I just kick it out of the way. Sorry about that. I need to go back to the breath. All right, you got your input, which is your water, and that's called your what? Your domain. The output is called the ice. And it's also called, in mathematics, it's called what? The range. So the ice machine itself is the what? It's the function. You have the same setup with a bicycle. All right? If you have a bicycle, you got to have legs to do a bicycle, to ride a bicycle. If you don't have legs, you fall down. All right? Somebody said they were offended because I said that. No, that's just a fact of life. All right? If you don't have legs, if you have prosthesis and they don't work, you'll fall down. So you have to get a bicycle modified to where you can either sit in it or whatever, so you can use your arms or whatever. Okay? You've got to have something going into a function for it to work. All right? You can't just have an ice machine sitting there plugged in with no water. Okay? So what is dependent and what is independent? Dependent. What does dependent mean? The motion is dependent upon, or the ice is dependent upon the what? No, the water. The range is dependent upon the what? So the range is dependent, and the domain is what? Why? Because you can't have ice if you don't have what?
Water.
Water. So the x values are always going to be your domain. And what is your y values always going to be? Your range. Now I have found that this is the best explanation for the function that I've ever tried to use in the 20 plus years I've been teaching, the ice machine. I've tried it with a hay baler, I've tried it with a bicycle, I've tried it with several things, but the ice machine works the best because people can actually relate and say, okay, I can five gallons. So the range is dependent upon the domain. You can't have the range if you don't have a domain. So when you're looking at this, and usually you can see this with a graph. Okay? When you're dealing with this, you can see it better with a graph. So if I have a graph here, and I have a parabola, then the value for that parabola and the y values is your range from 0 to infinity. The value for the x is from negative infinity to positive infinity because it has what on the end of the function? It has arrows on the end of the function, so it keeps going and going and going. Okay, so it's very important that you be able to see the domain and range on a graph and explain what the domain and range is as far as the input and the output. Now, the problem is that sometimes you have a function, and sometimes you have an equation, and sometimes you have an expression, and you need to be able to tell the difference between the three. And so that's where a lot of students get a little bit haywire, is because they don't know the difference between the three. So, here's an expression. An expression does not have a what? Does not have an equal sign. 2x squared y is an expression. If I told you to factor that expression, you would say 2 times x times y. There, boom. That's an expression. And then you have an equation. Equation has the what? An equal sign. So that means y is equal to x squared. That is an equation. The difference between a function and an equation is when you say function, you're supposed to hold your pinky up when you say it, because it's the same thing. A function is a fancy way of writing what? Y, Hubert. That's a function. So, you have been studying functions and equations since pre-algebra, and have you been studying the same thing? Yes or no? Yes, they're the same thing. What do you mean? Well, back in pre-algebra, and I'll wait for everybody to catch up writing. Back in pre-algebra, you learned how to add, subtract, multiply, and divide. Polynomials, or Algebra 1, 101, or 102, whatever. In 109 or 102, you were told f times g of x, f plus g of x. And that's basically the same thing that you were taught in pre-algebra. Let me show you what I'm talking about. Back in pre-algebra, or when I say before Math 109, pre-algebra to Math 102, Math 101, or Algebra 1, you were taught I need to add x plus 1 plus 3x minus 2. I need to subtract x plus 1 minus 3x minus 2. I need to multiply x plus 1 times x 3x minus 2. And I need to divide, I'm going to change it a little bit, x squared plus x plus, or x squared plus x over x. And you said, okay, I need to, and I'm trying to cover a lot of ground here at one time, so y'all just bear with me, because I'm trying to help the person out that hasn't seen this in a while. That's supposed to be x plus 1, sorry. Okay, so back then you were told to distribute the ones. Whatever's in front of the parentheses, you distribute, and you get x plus 1 plus 3x minus 2. And combine like terms, x plus 3x is 4x, and positive 1 minus 2 is negative 1. So your answer is 4x minus 1. And you were taught that, and then you were taught to put the negative out front. That's going to be x plus 1 minus 3x plus 2. And that's going to be x minus 3x is equal to negative 2x. And 1 plus 2 is equal to what? 3. And you were taught to do that. And then you were taught the FOIL method. Pronounce it however you'd like. And that would be 3x squared minus 2x plus 3x minus 2. Combine like terms. 3x squared plus x minus 2. And then you were taught x plus 1. And you learned all that in wherever, okay? Pre-algebra, Math 101, you learned all that. And then they turned around in Math 102 and told you, well, that's nice, but that's a little bit beneath us, so we're going to tell you, instead of doing it like that, we're going to tell you to say f of x, hold up your pinky, is equal to x plus 1, and g of x is equal to 3x minus 2. And I want you to tell me what f plus g of x is, and I want you to tell me what f minus g of x is, and I want you to tell me what f times g of x is, and I want you to tell me if we have f divided by g of x, if f of x is equal to x squared plus 1 and g of x is equal to x. Now somebody tell me what the difference is between all of that and what you did back in pre-algebra. There's not any difference whatsoever. But you would be surprised on how many students make the transition from 101 to 102, and they're told this, and they are totally confused, and they've been making A's and B's on all of this since pre-algebra. Okay? There's no difference whatsoever. So let's just get that out of the way. A function is the same thing that you've been dealing with way back. Okay? Because take x plus 1, and then we're going to add it to 3x minus 2. All right? It's the same thing that you've been doing. So I'm not going to spend a lot of time going over this because you know how to do it. It's just that you hold your pinky up when you do this. All right? So what about the composition, Hubert? We didn't do composition in pre-algebra. Yes, you did. It was called substitution. Back in pre-algebra 101, you were taught the substitution. Okay? You were given y is equal to 2x plus 3, and you were given x plus y is equal to 6. And what were you told to do with this 2x plus 3? You were told to plug it in for y. And then you said x plus 2x plus 3 is equal to 6. 3x plus 3 is equal to 6. X is equal to 1. Okay? That's substitution. You were taught that in Math 101 or maybe in the first part of Math 102. I don't know, or wherever. Well, how's that? Composition. Well, it does change a little bit, but the substitution is the same. All right? You can say f of x is equal to x plus 1, and g of x is equal to x squared. And I want f composed of g of x. That basically means that whatever this one is right here, whatever this one is, I'm going to rewrite that one with a big A set of parentheses, wherever there's an x. So which one's f? X plus 1. So I'm going to rewrite it as big set of parentheses plus 1. X plus 1. And then what am I going to plug into? What am I going to plug into f? G, which is what? X squared. So there's your substitution that you did back in pre-algebra. It's just a little bit different. And that's going to give you x squared plus 1. And f composed of g of x is equal to x squared plus 1. Now, if I gave you g composed of f of x, g composed f of x, I would rewrite g with a big set of what? Parentheses, and what would go in? X plus 1. And that would give us x squared plus 2x plus 1. Shortcut number 1. We're going to go over that in just a minute. Okay? Now, as I go over this, everybody should be saying, okay, there's three people in the room. Okay? The first person is the person that invented this stuff. Okay? They're sitting back going, oh God, I can't believe he's going over all this stuff. I've invented it. Okay. Stay home. Create a cure for cancer. Don't come to my class anymore. Second person is going, okay, I remember that, but I'm going to keep my mouth shut because I don't want to be a know-it-all. Okay, good. Keep your mouth shut. The third person is going, I'm glad he's going over this because I forgot. And the third one is the person I'm teaching, period. All right? So if you're that person, then good. Don't raise your hand or anything. But that's what I'm doing. I'm trying to get everybody up to speed. This first unit is nothing but review. Okay? It's a review over the stuff you learned in Math 102 or Algebra 2, depending on where you're from, as far as from high school or if you were from Tri-County Tech and taking this class after 102. All right? So that's composition of function. Can I compose f of f? That's a yes or no question. That means I want some feedback. Can I compose f of f? Yes or no? Yes, you can do anything in mathematics. Whether it's right or not, you know, that's debatable. But if I want to compose f of f, yes, I can compose f of f. F, hold your pinky up, f of x is equal to a BA set of parentheses plus 1, and then what do I plug into the parentheses? I'm sorry, I heard. What'd you say? X plus 1. Okay, now I heard x plus 1. Speak! X plus 1. And that's x plus what? X plus 2. Can I compose g of g? G composed of g of x is equal to a big set of parentheses, and then what's going to go in there? X squared. X squared, and what's that going to give me? X to the 4th. So you can compose f composed of g, which is fog, or you can compose g composed of f, which is golf, or you compose f of f or g of g. Those are 4 operations that you can do with composition of functions. Again, you should be saying to yourself, okay, I remember that. Glad he's going over it because I've forgotten it. Now, we've talked about so far, we've reviewed over, and we reviewed quickly because I do believe that y'all have seen all of this before, and I'm going over it kind of quickly. I want you to do the homework and then send me what? Questions, because if you send me questions in chapter 1, that's going to tell me how much I need to review come Thursday. Okay, if I don't get any questions from the homework on chapter 1, then I'm going to assume that you what? Know it. We're going to move on. So, what next? Well, don't forget about, we've gone over addition, subtraction, multiplication, and division. And we've also gone over substitution. But what about a little bit more of this called factoring, and a little bit more of this called multiplying / distributive law / FOIL. Okay? Factoring, and we also use the shortcuts also. What the heck is he talking about, the shortcuts? Well, let's go ahead and review the shortcuts. And I'm just covering all of this because I know we're going to use them. All right? And I'm trying to get all the review in algebra I can. All right? So here we go. 1. Shortcut number 1. A plus B, quantity squared, is equal to A squared plus 2AB plus B squared. A minus B. Shortcut number 2. Quantity squared is equal to A squared minus 2AB plus B squared. 3. A squared minus B squared is equal to A plus B times A minus B. Number 4. A cubed plus B cubed is equal to A plus B times A squared minus AB plus B squared. And shortcut number 5. A cubed minus B cubed is equal to A minus B times A squared plus AB plus B squared. Okay, that is the 5 shortcuts. Now, why do I show it to you when I mention multiplication and division? Well, you can use both of them depending on what you're being asked. Okay? If you go this way, you're multiplying. If you're going this way, you're factoring. But it's the opposite with the others. Okay? If you go this way, you're multiplying. If you go this way, you're factoring with the others. Multiplying, factoring, multiplying, factoring, multiplying, and factoring. Okay, it all depends on which way you're going. Now we're going to review a little bit about this, and then we're going to go into graphing, because I think that we're going to pretty much cover graphing, the review of graphing, because I did see a lot of graphs in there where you're finding the domain and the range. So we're going to, look at graphing right quick. So let's do an example of 1 or 2 of these, just to kind of brush you up. And I may be getting the cart before the horse a little bit, but I know we're going to go into it eventually, so it doesn't hurt to go ahead. You may not have any of this in your homework, but you're going to have it probably in Unit 2 or Chapter 2, I don't know. All right, so let's do something simple. X squared minus 4. Now the first thing you do when you use the shortcut is you go into Sherlock Holmes mode and you use the law of what? Deduction. Which one is it not? So you look at x squared minus 4. Which of the 2 of the 5 is it not?
5.
It's not 5 or 4. Why? So those are perfect cubes. Okay, so you right off the bat say, okay, it's not 4 and 5, so it's got to be 1, 2, or 3. Which one on the left-hand side of the equal sign does not have parentheses? Number 3, so it's number 3. So you put the shortcut under the problem. A squared minus B squared is equal to A plus B times A minus B. Well, we need A and B because this is our answer. We need A and B, so A squared is not going to help us and B squared is not going to help us, so we need to take the square root of everything, and that's going to be A is equal to what? X, and B is equal to what? Be 2, and you plug it in because that's this and that's it. The negative tells you it's shortcut number 3. And we get x plus 2, x minus 2. So at this point, you should be saying, oh yeah, I remember those. I remember those 5 shortcuts. I remember. I'm glad you did that. Okay. All right, now let's give you another one. Let's give you one, and you figure out which one it is yourself. All right? How about this? So which one is it not? It's not 1, 2, or 3 because those are all perfect what? Squares. So it's got to be 4 or 5. Which one is it? 4. So you put it up under it. A cubed plus B cubed is equal to A plus B times A squared minus AB plus B squared. Take the cube root of everything, and you get A is equal to X, and B is equal to what? Plug and chug, you get X plus 5 times X squared minus 5X plus 25. Okay, like I said, that should be a little bit of review for you. Everybody should be going, okay, I remember how to do that. And you can go the other way also. I'm not going to go through that because you'll probably see them in your homework. It's either chapter 1 or chapter 2 or somewhere down the line. All right, there's 3. We're going to go over the third part of the review, which is graphing. And then after I go through graphing and exponential laws, we're going to be able to actually look at the problems that are in the homework and see what I can do to help get through those, okay? Because I have no idea how in depth they're going to go into a review. So, graphing. There's several properties of graphing. There's 2. Y is equal to mx, or y is equal to mx plus b. To find the slope, calculate the slope, delta y over delta x, which is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if you're given 2 points, 2, 3, 8, 6, then you go from left to right, and you say, okay, this is x sub 1, this is y sub 1, this is x sub 2, this is y sub 2, and then you plug and chug. 6 minus 3 over 8 minus 2, which is equal to 3 over what? 3 over 6, which is equal to 1 what? 1/2. So your slope is 1/2. Okay? Y is equal to mx, or y is equal to mx plus b. That's your general form of a line. That don't look right. General form of a line. Did I say a curve or a line? I said a line because your variable, your x, is raised to the what power? To the first power. When you have x to the first power, that means it's a straight what? Line. Just remember, a 1 is a straight line. We're going to move into the family of graphs in just a second, and then you'll see how all this ties together. I'm trying to do everything as quick as possible for the review, okay? Remember that m sub 1 is equal to m sub 2. That is what? Parallel lines. And m sub 1 times m sub 2 is equal to -1. That's what kind of line? A squiggly line that I didn't draw, and another line that I didn't draw. Damn Russians. What kind of line is that? What's the opposite of parallel?
Perpendicular.
Thank you, class, for the interaction. All right? No coughing in class. No coughing, no yawning, or no sneezing. All you can do is breathe. All right. What about those slopes? What else can you tell us about slopes? Well, when x is equal to a number, like x is equal to 2, x is equal to 4, x is equal to -1/2, what are all those? When x is equal to a number, that means it's parallel to what? It's parallel to the y-axis, which means it's a vertical line, which means that the slope is equal to what? Undefined. What about y? When y is equal to a number, y is equal to 4, y is equal to -2. What kind of line is that? It's parallel to what? It's parallel to the x-axis, which means it's a what? Horizontal line, Hubert. Thank you, class, for the interaction. M is equal to what? M is equal to 0. Question so far. Again, on a scale of 1 to 10, with 10 being difficult, these are all things that should be below a 3. All this should be kind of, knocking the cobwebs loose. Okay? After you talk about the properties of lines, then you also have the 3 methods of graphing, which we're only going to talk about one because we're going to be dealing with curves. All right? And that is the second method of graphing. The first method of graphing. Okay? Everybody got this? All right? The first method of graphing is the chart plot method. Chart plot, you have an x and a y. Y is equal to x to the second power. So I always choose -0, +1, +2. I always choose 5 points. And this is something I always do. I always choose 5 points, and I always use the same 5 points unless it's a fraction, and then I choose multiples of the denominator. So that'd be 4, 1, 0, 1, 4, and that'll give you a parabola. And we'll talk more about this after we talk about the different methods of graphing. That's a parabola, it looks something like that. Second method is called the intercept method. That's the second method. We'll just put a Roman numeral 2 here. 1. I wish this board would quit drawing whenever I move from the... Second, if I give you 2x plus 3y is equal to 6, and I put, for the x-intercept, I put in 0 for y. For the y-intercept, I plug in 0 for what? X. 0 for y, you get 2x plus 0 is equal to 6. X is equal to 3. Here, you plug in 0 for x, you get 0 plus 3y is equal to 6. Y is equal to 2. And you plot your points. 3 and 0, 0 and 2. Again, this is straight line method. So 3 and 0 is the x-intercept, 1, 2, 3. And 0, 2 is the y-intercept. So that's the intercept method. And let me go ahead and minimize this. Now, if I'm going too fast, you just let me know. Again, I'm trying to fill y'all out. You're trying to fill me out. I'm trying to get everybody on the same sheet of music. Eventually, what's going to happen is everything's going to level out. I'm going to get you where you need to be, and you're going to figure out how fast I go. You're going to just kind of, balance out. The third method. Third method is what we call slope intercept. Again, it's with a straight line. Y is equal to 3x plus 2. The y-intercept is 0, 2. That's your y-intercept. You got a positive slope because of this positive right here. That means left to right up. And then 3/1 is your vertical over your horizontal. You draw a graph. Put your y-intercept. And then you count 3 down. 1, so trace line's going this way. Left to right up. 1, 2, 3, 1. 1, 2, 3, 1. I do that because some people think you have to go positive, and no, the trace line tells you how to go. So you don't need to do that silly rule that teachers that don't know what they're talking about teach you. Okay? It's vertical over horizontal. Positive only tells you the direction of the line. It doesn't tell you have to go a certain way. It tells you the direction of the line. Okay? That's the properties of graphing, and that's the 3 methods of graphing, all in about 10 minutes. Okay? So again, you should be saying, oh yeah, I remember that. We're going to focus on this one because this is the only method that will give you a nonlinear. And your calculator. Okay? Capiche? Now, Pendleton, y'all can look at that other board over there. You know, that whole board over there is for y'all. Y'all kind of looking at the monitor and straining your eyes. You don't have to strain your eyes. You can look on the other side over there. All right. Questions so far? Now, like I said, I want you to take a piece of paper out, and I want you to turn it landscape, and I want you to divide it into 8 boxes. Take a piece of paper, landscape it, and turn it into 8 boxes. So I guess you can fold it and divide it four ways on line, or you can take a straight edge and draw, or you can just hand. I don't care how you do it. It's for your notes, okay? So it's not going to be turned in or anything. But this is called 2 things: family of graphs and parent graphs. Family of graphs and parent graphs. So however you want to call it. And some of you, again, have seen it before, so it's not a big deal. So I'm going to take my handy dandy straight line maker. And I'm going to draw lines going across here. And there we go. That's what your paper should look like, except for the crooked lines, okay? And the first one we're going to put up in here and draw. You want to draw 4 graphs, x-y axis like this. Leave space for you to write top, sides, and bottom. So after you draw, and the more accurate you make this, the better. I mean, the more decent you make it. And leave you some room at the top and the bottom to write. Now remember, we're in high society, so everything has to be a function. Everything has to be a function. So f of x is equal to x to the first power. F of x is equal to x to the second power. F of x is equal to x to the third power. F of x is equal to x to the fourth power. F of x is equal to the square root of x. F of x is equal to the absolute value of x. Oops. F of x is equal to 1 over x. And f of x is equal to 1 over x squared. Now, if you draw a sample of each one, you want to draw the basic sample. What is the basic sample? Well, everybody in here has bought a car or has been around somebody buying a car. What different types of cars are there? Let's say a Mustang, all right? I personally go by the trucks because I don't think I've ever owned a car. I think I've owned one car, that's back in high school, and it was a piece, so we won't even talk about that. But if you get a Mustang, what's the different types of Mustangs? And we'll just narrow it down to 2018, okay? What's the different types of Mustangs you can get?
How many cylinders?
Exactly, different engines. What else? Different hatchbacks, hatchback, coupe, right? You can get different wheel package. You can get different engine. You can get different what? What's on the inside? Interior. So, but what is the basic model of Mustang? Basic. Dang old radio, maybe air conditioning, maybe, with maybe a four-banger in it. They still sell Mustangs with a four-banger in it. I know in the 80s they did, in the 90s they did. Remember that? And people would try to put duals on it, and it sounded like a sewing machine going down the road. Kind of like these guys with the smokestacks on their truck. There he is. Anyway, they're overcompensating. But anyway, there was this one guy. He was here a couple of semesters ago. He had a Ford Ranger with a smokestack coming out of the back of it. It sounded like a sewing machine going down the road. Females, smokestacks equals run. Run as fast as you can away. Okay? Run. All right. So, especially if it's a Ford Ranger, the four-banger in it. Run. That's just, if you see sunglasses in the gym, run. Far as you can. Fast as you can. All right? And $10,000 wheels on a $1,000 car. Run. Guys, you got it simple because you're not that complicated. Just Oompa Loompas. If you ever see a girl with an orange face and a white neck, run. Fast as you can. Because she will take a ball bat to your headlights. Okay? Run. All right, so we got that straightened out. Everybody knows who to run from now. Okay? First of all, x to the first. We talked about it. The basic model is a what? Straight line going through the origin. That's called what? Linear. That's a straight line. The basic parabola goes through the origin. All these go through the origin pretty much because they're the basic model. They're the basic model with air conditioning and what? Maybe an AM/FM stereo, maybe. That's a parabola. Do like I did. Go to Math 110 and call it a parabola. And Dr. Gabati said, I do not understand what you're saying, but I dropped him. Anyway, parabola. That there's a parabola. He didn't like me very much. I think our culture's conflicted a little bit. Redneck versus not from around here. I think it kind of. I'm much more refined and polished now. Anyway, x to the third. I don't know what you call it, but that's what it looks like. X to the fourth. This is called a quartic. Now let's bring up a quartic. The difference between a quartic and a parabola is the higher up the exponent, the more you're going to see a squaring off of the what? The bottom. So you need to write down two things. First of all, you need to go over here and you need to, I'm going to try to do this for you. I'm going to put f of x is equal to x to the odd power. And I'm going to highlight that odd so you'll remember it. Because they're all going to look like that behavior. Okay? It's called ending behavior. Write that down. Those two, that's called ending behavior. And you're going to see that again probably in your homework. This one is called f of x is equal to x to the what power? Well, what's the opposite of odd? Even. You're so smart. And that is going to be ending behavior like this. So if I give you f of x is x to the 5th power, what can you tell me? You're going to have arrows going in what directions? Opposite directions. What if I give you x to the 8th power? What are you going to tell me? Arrows going what? Same direction. With the parabolic shape. All right, now the square root function. Square root function is a swish. Like that. Always going to be a swish to the right. Always. Why? Because you can't take the square root of what? Negative. So it's always going to be to the right. Now the absolute value is easy to remember. Absolute value, absolute vodka for you alkies. Okay? Absolute value, absolute vodka. What does that value in vodka start with? Dang old Alcoholics Anonymous. Okay, absolute vodka, absolute value. I'm not a vodka fan. Never have been. Oh my God, I said vodka in class. I heard you said vodka in class. But history teachers and psychology teachers can talk about the things they talk about. I can't even, if I was to say the things that they talk about, somebody'd say, Hubert said this in class. I don't know why I get crazy people. Half a volcano. 1 over x always gives you half of a volcano. What are you talking about, Hubert? Well, here's the full volcano. Now you see the half of a volcano. That's your family of graphs. What the heck does that mean? Well, all these are your basic models. These are your basic truck. That's your basic truck. That's your basic station wagon. That's your basic Mustang. That's your basic Taurus. That's your basic Neon. That's your basic. In other words, these are all the basic models of different whatevers. If I say cars or trucks, in this case, it's the basic functions. Now, if I put any bells and whistles on those functions, it's going to be orientation, it's going to be a vertical shift, and it's going to be a horizontal shift. That's your bells and whistles. Your air conditioning, your power windows, your heated seats. I'm going to add to these basic models and tell you how to look at a function and be able to tell what's what. Well, let's talk about that. All right, so everybody got the basic functions down. This is one of those sheets that you need to memorize. This is one of those sheets that you need to put a star on, and you need to say, I need to memorize those. Yes, you do. Because a whole unit is based upon these transformations. It's called transformations. Is there something where's transformations in here? You see anything that says transformations? Vertical, horizontal shifts, transformations. Well, they're in there somewhere. It's either Unit 1 or Unit 2. And like I say, this is going to level out when I start looking at the homework problems and I'll start taking some from here and putting over here, and I'll start putting some off for later, and it's going to level out.
It's 4.1.
4.1, which is Unit what?
Unit 2.
Okay, we're getting there. All right. So, this is your functions. These are your ice machines. These are what you're going to plug in numbers, and you're going to get your, and let's go ahead and do that. Take your highlighters out. If you got different color highlighters, let's go ahead and highlight each one of these in yellow, or let's go with green. Verde. Dang old Verde. Dang old West Bay yellow. All right. Verde, here is your, I'm sorry, that's your range. Hold on. There's your domain right here. Domain. Now I'm just going to draw to the arrows so you can see the domain. I'm just doing it just so you'll see the domain. of these functions, even though they keep on going? There's your domain. Notice that these two do not touch. They're not supposed to touch the x-axis because the function never touches the x-axis. Those last two. You need to make a note of that. Draw a circle right here and draw it in red and say do not touch. Does not touch the x-axis. Your range, your domain is from negative infinity to 0, non-inclusive of 0, then from 0, non-inclusive, to infinity. It does not touch 0. That's your range. Your domain. Okay, what about the range? Well, we'll take our handy-dandy aquamarine, aquamarine, and that's going to be our range. So here, our range is going to go there. Here, it's 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 going to go there. Here, there. Here, there, and here, there. So there's your domain and ranges for those parent functions. Now, of course, it would be nice if you could go through and name those, which this one would be negative infinity to positive infinity. This one would be from 0 to positive infinity, negative infinity to positive infinity, 0 to positive infinity, 0 to positive infinity, 0 to positive infinity, negative infinity to positive infinity, 0 to positive infinity. If we did the domains would be from negative infinity to positive infinity because we have arrows on the graph. Negative infinity to positive infinity. Negative infinity to positive infinity. Negative infinity to positive infinity. Remember, the domain is not affected unless you have a radical or a fraction. If you have a radical or a fraction, your domain is going to be affected because what can you not take the square root of? Negative. What can you not have in the denominator? 0. So those two things are affecting the domain, and that's why here is from 0 to what? Infinity. Here, negative infinity to positive infinity. Fraction. From negative infinity to 0, and from 0 to positive infinity, but you do not touch 0. Same thing here. Negative infinity to 0, do not touch, and 0 to positive infinity. So there's your domain and ranges for your parent functions. And we'll get into that a little bit later when we do vertical and horizontal asymptotes. We'll get into that. Okay? So now we got domain and ranges. Now, let's take a look and see what kind of problems we're going to get into with the homework. No sneezing in class, please. There was actually a teacher. Did I tell you about the teacher? If you yawn 3 times, she threw you out of class. She only lasted 1 semester. She never did come back. I guess they fired her ass. I'm sorry, they fired her. That's about stupid. Oh, you yawn 3 times, you don't come back to class. Whatever. Yeah, have y'all seen any of these teachers like this? I mean, it just blows my mind. Well, I had one teacher at Clemson, and he would lock the door at 8 o'clock. These people are loony.
There was that teacher who got mad. The kid got mad.
Yeah. Don't say ma'am. Don't say ma'am to me. Don't say sir to me. Yeah, don't be respectful. I'll throw you out of class. Whatever. All right, here's a question right here. And if you have to, connect the dot. Draw the picture. I'll make it as big as I can. Now, there's one thing we can't do here. I can't make it bigger. Wait a minute. Hold on. Oh my gosh, they've added that. They used to not be able to do that. All right, there's the function. I want you to tell me the domain and range of that function. So what I would do is I'd take my handy-dandy highlighter and I would draw a line connecting those dots, because that way you could see it a whole lot better. So take your handy-dandy highlighter or pencil. And you have a curve button. I don't have CAD, so I'll just have to do the best I can. There, 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 there. And there's your function. Do we have arrows, yes or no? No. So put a dot here and a dot there to make sure you understand there is no arrows. So therefore you have a definite domain and you have a definite range. Let's highlight our domain, because I think it's always good to see it before you. There's your domain, and your range is right there. So let's write it. Now we're going to write interval notation because that's the way I write. I don't care what the directions say, but I'll show you what set builder notation is. And again, is that new or is that review? Review, Hubert. That's right. So, set builder notation, I'll write it over here for you. Set builder notation. All right, so I'm on my domain. It's going to be X such that X is between what? -7, good. Glad you're participating. -7 and what? 5. Now, Pendleton, Easley, and Oconee, y'all can interact, okay? Y'all can answer questions. Y'all know that, don't you? Yeah, Hubert. Thank you for interaction. Appreciate it. Range. Range. Not X, but what? Y such that Y is between what? -6 and what? 4. That is set builder notation. Why do I not like it? To me, you're going around the world to tell you, well, something simple. Interval notation is what a lot of teachers use because it's short and sweet. Interval notation, bracket means conclusive, means inclusive. Sorry, not conclusive. Inclusive means that you include it. That means it's got a solid circle. So negative what? 7 to what? To 5. Oops. That's your domain. Range is going to be inclusive because you have solid dots on the end. From what? -6 to what? To 4. That's your domain and range. It's not that difficult. You would be surprised on how many people have taken Math 101 and 102 or Algebra 1 and 02 cannot tell you what the domain and range is. Real simple. You get out of it what you put into it. In this function, the numbers that you can put into it is -6, 4, and the numbers. Are y'all going somewhere? Because look down here. I got 3 minutes. So whoever's doing the packing up, that's rude. Whoever's doing it. Don't know who's doing it, that's rude. Okay. So the only numbers I can use are -6 to what? +4. What's the only numbers that are going to be spit out of this ice machine? -7 to what? +5. Okay, so right now you are responsible for Chapter 1 homework. Now, you may not be able to do some of it. Send it to me. Okay? You may not be unclear. You may be unclear of some of it. Send it to me. That way I can tell where y'all need to review and where you don't. Capiche? Okay, now you can pack it up and not be rude. I haven't done that. Okay, I'll check it after class. I'm going to check the homework after class and assign it. So I'll assign Chapter 1. I'm not going to assign any other part. I'm going to call the roll, and I'm going to call the satellite campuses before they have a conniption. All right. Burgess.
Here.
Butler.
Here.
Can.
Here.
Davis. Davis. Franklin.
Here.
Griffith.
Here.
Were you here the first 2 days?
Yes, sir.
You didn't answer? Okay. Kinley or Jonathan?
Kinley.
Okay. All right. Hamby.
Here.
Heath. McCollum.
Here.
Meredith. JC. You here? Roach.
Here.
Saliba. David Saliba. Okay, that person was to drop. Talbert.
Here.
Anybody's name I didn't call? Wait until I finish. Okay, this is the... I'll get Anderson last if y'all don't mind. These people are going to have conniptions if we don't let them go. Bixler.
Here.
Collins.
Here.
Martin.
Here.
Page. Both of you.
Here. Here.
Terry.
Here.
Leonhard is here. Lust. Lust. Oconee campus. Lust.
Hello, I'm here.
Okay, you're supposed to say something because that camera don't go to motions. Speed.
Here.
Okay, and the Anderson campus. Brady.
I'm actually just the green.
Callahan.
Here.
Dean.
Yeah,
Floyd. Gully. No Gully. Ford. And Can. All right, anybody got any questions? Holler.
Actually, Vickery added.
Okay, where is she? Miss Vickery? Where
right
are you?
here.
Okay, Miss Vickery, give me your first name, your last name, or Vickery, duh. Okay, you the one that spoke to me the other day. Did your daddy remember me?
He did.
He did? I didn't
Yes,
think
sir.
he would. I thought that's a long time ago. First name?
Ashley.
Ashley, and middle initial?
B.
Ashley D. Okay, I got you entered today. Thank you, ma'am.
Thank you.
Okay, rest of y'all, have any questions? Let me know. Who's that? Miss Jordan.
Yes.
Okay, which campus are you on the roster of?
Oconee.
Oconee, okay?
So I'll be there Thursday instead of here.
Okay, let's see. Okay, you must have added late. Did you add late?
I did, yeah.
Okay. Jordan, Jordan, first name?
No, that's my last name.
Okay,
Taylor.
what's your first name?
Taylor.
Say it again.
Taylor's my first name. Jordan's my last name.
Taylor is your first name.
Yes.
Okay, and you entered today, correct? Or did you enter the first?
I entered last Wednesday.
Okay, I'll put you down as entered Wednesday. I don't know if it's on I'll have to look on the attendance, but I got you down for today and Wednesday, okay?
Okay, thank you.
All right.
Homework due on Thursday. Guessing it's just one for one.
Yeah, I guess.
It's probably the only thing that's
You see
assigned.
all over came out like